remark. So let C is subset of B. So then what can be the inverse image of the set C? So if this is set A, this is set B, and f is function from A to B, and C is some subset of B. So what can be the inverse image? So there is no definition for inverse function. So we define function f from this way, from A to B. So ultimately, if the inverse function, if it exists, it can be defined by the reverse way, from B to A. Right? So because of definition of function, what happens? We have considered that this case also can be a function. So it means that these three elements from the domain are maps to single element in the codomain. It can be a function. So can you say something about inverse image of this single element? So inverse image of this single element must consist of, or must include, all these three elements from the domain, right? So what should be the inverse image of the set C? So it should be collection of elements from the domain, for which their images should be forced in set C, right? So that their images should be in set C, right? So what happens if C is a set with single element? If set C has only single element, so we can write inverse image of singleton Y. It can be written as inverse image of Y. So we cannot say that if f is function, we cannot guarantee that the inverse image of single element Y will be a single element, right? Because what we have seen here, the case is three elements in the domain are mapping to single element in codomain. So definitely the inverse image of this element should have all these three elements in the inverse image of this element, right? Therefore, what can be the inverse image of this set Y now, according to this definition of inverse image of set subset C of B? So it should be collection of elements from domain A, so that f of A is equal to Y. So those elements in the domain which have the image or output Y in the codomain B. Right? Second remark, let D is subset of A. D is subset of A. Then what can be the image of set D? If this is set A, this is set B, f is function defined from set A to set B. If I have subset D of B, so as f is function, so these elements will map somewhere, right? So the image should be, image set should be subset of B, right? So it will be collection of fx such that x is element of D. So it is nothing but collection of elements from the domain, codomain. Which elements? Which have pre-images in D, which is subset of A. So it is nothing but f of D, which is nothing but image of D under function f. So let us see some example. So we consider the set f, which can be the Cartesian product or order pair x comma x square such that minus infinity less than x less than infinity, and it is function. It is which function? Is a function y or f of x equal to x square. The input is x, output is x square. What is the domain? Minus infinity to plus infinity. Therefore, what can be the domain of function? Domain of f is minus infinity to plus infinity, or a real line. Or you can simply write minus infinity to plus infinity. What can be range of function? If I have function f of x equal to x square and input is given from minus infinity to infinity, real numbers. So what would be the squares? Square of 0 is 0 and square of positive reals will be positive, square of negative reals will be positive, right? So the minimum value will be 0 and maximum value may be large, depends on the input. Okay. So what can be the image of 5 under function f, which is f of x equal to x square? So the image of 5 will be 25. Image of minus 3 will be its square, 9. So the inverse image of 4. What can be the inverse image? Because under this function element 2 will have square 4 and element minus 2 will also have the square 4, right? So there are two elements, 2 and minus 2, those are mapping to 4 under this function, right? So if we want to see inverse image of 4, so it should have two pre-images in the domain, namely 2 and minus 2. So 2 and minus 2. Can we see inverse image of minus 2? Can we have some element in the domain which maps to, which have output minus 2 in the codomain? No. Under this function y, f of x equal to x square, no element is there which have square minus 2, right? So such element does not exist in the domain. So the set is empty. What can be the image of function 0, 5? If I consider the interval closed at 0, open at 5, so what can be the image? So the image under this function f of x equal to x square is, it can be 0, 25 and it is open at 25. The next remark, number 3. The equation or expression given by fx it does not define a function. It does not define a function until the domain is particularly specified. Until the domain is explicitly specified. For example, suppose I have two functions. Fx is suppose sin x with a domain suppose 0 to pi, and let gx to be, suppose it is again sin x, and the domain suppose 3 phi. So these two functions have different graphs, right? It will have the only half loop, and it will have one completed loop and half more loop, right? So represents or defines different functions. So the function fx will be a function if the domain is particularly specified. So the next definition is the extension or restriction of function. Extension or restriction of function f. So suppose the definition, suppose f and g are two functions with domains x and y respectively. If x is subset of y and if fx is equal to gx, for all x in x. So observe that x is subset of y and the images of f and g are same for all x belongs to x, for all the elements of x, right? X is subset of y, f is function with domain x, g is function with domain y, and x is subset of y. Observe that. One more thing, images of f and g are same on the domain x, right? Now observe that g has domain larger than x, right? So then we can say that g is an extension of f to y, or either we can say g is an extension of f to y, or we can say that f is the restriction of g to x. So we can write if we restrict g on x, so it will be same as f for all x in x. So symbolically we can write by this way: if we restrict g on x, it will be same as f. Images of g and f are same on set x. One-to-one function. So generally, if f is a function from a into b, so if f is a function from a into b, so we write f is function from a into b. So what is the one-to-one function? So if f is a function, then f is one-to-one if f of x1 is same as f of x2 for some x1 x2 in the domain of function should implies that x1 is same as x2. That means f is one-to-one function if the two images are same in the codomain, so their pre-images in the domain must be same. So it means what? Simply it means if x1 is not equal to x2, so it should imply that their images should be different. Right? One-to-one function means if the images are same in the codomain, their pre-images in the domain must be same. Simply the other meaning can be different elements in the domain should maps to different elements in the codomain. Right? So let us take some example. For example, if we can have function fx to be e raised to x and it is defined on minus infinity to infinity, defined on R. So you can check by graph of the function is a one-to-one function. Since for x1 x2 in the domain, suppose their images are same, that means e raised to x1 is same as e raised to x2, and by the using the rules of exponent you can simply say that we can get x1 is same as x2, right? So the function is one-to-one. If we consider other function equal to x square and it is defined on real numbers, so it is not one-one, is not a one-to-one function. Why it is not one-to-one function? Because f of minus 2 is 4 and f of plus 2 is also 4. So minus 2 and 2 are different elements and both are mapping to the same element 4 in the codomain, right? So it does not satisfy the definition of one-to-one function. If the images are same, their pre-images should be same in the domain, but it is not the case. Even though the elements in the domain are different, they are mapping to same element in the codomain. So it is not a one-to-one function. The next definition is onto function. Let f from a to b is a function. And how to say that? Function f is onto. Then if the range of f is all of b, we say that, or we can say that f is a function from a onto b. It means what? F from a to b is onto map if a range of function f is the whole codomain B. That means all the elements in the codomain are used. Every element in the codomain is image of some element in the domain. Right? So, for example, if we take fx equal to x square, which is defined on R, so is not an onto function. Why? Because all element in the codomain are not used in this case, right? Because in this case f is function defined from real numbers to real numbers, so all the elements in the codomain are not used. Every element in the codomain is not image of some element in the domain, right? Because there does not exist a pre-image for -2 in the codomain, right? So f of -2. Why? Since f of -2 does not exist in codomain, right? The second example, if we consider function x cube, which is defined on the same set of real numbers, and observe that is an onto map. Because every element in the codomain is image of some element in the domain. So since for the element cube root of y in the domain A, here A is same as B is same as set of real numbers. There exist real number x in for this real number in the codomain there exists real number x such that it is same as x, that is y or f of x is equal to x cube. Therefore the function is onto.